We're in example 2 now. We're still in section 7.1, example 2. Now we're going to talk about finding the greatest common factor, a GCF. That is the absolute biggest number that's shared by 2 or more numbers. And so this is going to be a skill that we need to use, and we're going to use some of the skills we built in example 1 to help us get there. So we're going to find the GCF of 24 and 60. Now, your book gives you 2 methods. I personally do not care which method you personally choose. That doesn't bother me at all. You do what works for you, and I'll show you 2 ways to do it. You can figure it out, okay? So let's first put both 24 and 60. Let's write those down, okay? I'm going to give a little space in case we have to write out some numbers, long columns of numbers. Method 1, we're going to list the factors. A factor is just any number that, when multiplied by another number, gives you the given number. So our given number is 24. We want to write factors of 24. When I do this, I typically start at the lowest, which is always, a number always has a factor of 1 and itself. So we'll start with 1 and 24. And I kind of make a bookend, start with lowest and highest. Lowest I write to the far left and highest to the right. And then I work my way in. And I know 2 goes into 24 12 times. 3 goes into 24 8 times. 4 goes into 24 6 times. 7 doesn't go into it, and then once you hit 8, you're starting to repeat again, and it's already written, you don't need to write 8 again. So here are the numbers that are factors of 24. So you're literally going to go through 1 through 24 and find those factors. And that's how I do it. I do them in pairs, and I write the lowest number to the left and the higher number to the right. That's just how I do it. Okay, list them in order. It's basically what I'm trying to do. And I do them in order. Makes it easier to spot that common factor. Now we're looking for more than just a common factor. We want the greatest common factor. Okay, so let's go to 60 now. And I do the same thing. Every number always has, for factors, 1 and itself. Always. Okay? So I know 1 times 60 is 60. I know 2 goes into it. It's an even number, so that's 2 times 30, 3 times 20, 4 times 15, 5 times 12, running out of room here, 6 times 10, 7 doesn't work, 8 doesn't work, 9 doesn't work, and then we're repeating again with 10. So I just ran out a little bit of room here, but here's, if I write it out a little bit neater, 1, 2, 3, 4, 5, 6, and then I bump to 10, 12, 15, 20, 30, and 60. So that, if I write it out in a straight line without any interruptions, those are my numbers. Now what I do is I start at the highest end and I work my way down until I see a common number. So I don't see 60 in the other list. I don't see 30. I don't see 20 or 24. I don't see 15. Look what I found. Oh boy. 12 is the biggest number that's on both lists. 12 is a factor of 24. It's also a factor of 60. And this would be our greatest common factor right here. Okay? So you could do it that way. That may seem more laborious to you. I don't know. Do what works best for you. Now, method 2 asks you to use your prime factorization, which means you would need a factor tree. Now, the good news about this is it might actually be a little bit quicker. The bad news is the prime factors don't consider the number 1. Sometimes, like let's say we had, we were asked to find the greatest common factor of 3 and 7. Listing the factors would actually be a better choice because they're both prime. And what number shows up on both lists? Right, 1. And so 1 would be the GCF. That would be the only time that like a factor tree wouldn't be helpful to you, is you don't use a factor tree on a prime factor anyway. And listing the factors may actually be a better idea for something like this, okay? All right, so let's get back to 24. So we got 24, so let's do 2 and 12, which breaks down to 2 and 6, which breaks down to 2 and 3, okay? So I've got 2, 2, 2, and a 3, all right? And then 60, let's do 2 and 30, 2 and 15, 3 and 5. And so I've got 2 2s, a 3, and a 5. Now it actually looks really good if you stack them on top of each other. So let's do 2 2 2 3, and then 2 2 3 5. And look what matches up. Okay, do you see the pairings that are on both lists? I have a 2 that's on both lists, I have another 2 on both lists, and I have a 3 on both lists. If you multiply 2 times 2 times 3 together, you're going to get 12, which is your GCF. Method 2 is probably what you're used to seeing. That's probably the way that you're accustomed to seeing it done. Do it however makes sense to you. It really doesn't matter. I told you kind of some of the pitfalls for only using prime factorization, especially if you have prime numbers or numbers that their only GCF is the number 1. So anyway, I just want to point that out to you. If you will move down your notes and try this one for extra credit, use any method, I don't really care. And I'll give you 2 points for that one. Thanks for watching.